10:30 on a Tuesday night, just like Brian Wilson did. All right, back at the Sagami lathe. So I polished the edges, chamfered the edges. I used the flap wheel and the Dremel that was tapered, and I just touched them. Not the bores, but the edges. So I got my piece of my mandrel through the whole thing, a very light push fit, and it spans both of them. So the bores are not off as the light had indicated. It was actually a burr holding it askew. They're not totally coaxial, just the shape of that casting, and it was made in 1951. The lathe was. So anyhow, this bore saddles on a bushing and tightens up, and this is the swing axis to tighten the belt, and then that 3/8/16 tapped hole is with the bolt that binds it from swinging to hold the belt tension. But anyways, can we do this? Yeah, we can do this, and we can do that, and we can actually do that, and then we can, oops, come on, Doozer. The money shot. Okay. All right, so we're going across that face. That's 8 thou total. One revolution is 8 thou. So we're at 1. So there's 1 thou, 2 thou, 3 thou, 4 thou, 5 thou, 6 thou, 6.5 thou. 6.5 thou across the face of that, and let's rotate it. 1, 2. Whoa. So it takes a jump. 3, 4, 5, 6, 7. That's where we started, so it's 8, 9. So it's on the 4 there. So that's 8, 9, 10, almost 10. So 9.5 thou run out. 9.5 thou run out there, and I forget what we said going across. But it sits flat. There's not many points of bearing. It's, you know, but that's the surface. Can you guys see? We drifted or what? But anyhow. Yeah, let me do that again just so you can see. Like I say, all the way around is 8 thou. So that's 8 thou, and then it goes back past 8, 9, 10, 9, 8, whatever. And then, like I say, if you go across, there's 4, 5. That's okay, so let's count. 1, 2, 3, 4, 5, 6. So it's 6 across and 10, you know. So, like I said, this surface in my mind should be the aligning feature for this entire casting, and therefore the shaft, because that controls the gear mesh. I know this thing comes into, well, all right, let me zoom you out, right? Zoom you. In is out, out is in. Okay. So this, you know, swing thing contributes to the alignment too, but when you bolt that tight, that whole face, should align everything and control the pitch and yaw, the gear mesh, you know. And you know, it worked satisfactorily, except the bushings were completely freaking shot. So my plan is to put the needle bearings in here in both sides. And there's probably a thou of clearance in the needles. Maybe. We'll see. I could take this casting to someone with a Sonnen rigid hone and have it stroked out for straightness, but that wouldn't do anything for my alignment. See, right now, so what I'm doing, and I'm sorry if I didn't begin at the beginning, by making this mandrel, putting them through both bearing bores, if they're out a little bit, I'm averaging the amount that they're out, because, you know, it does fit in both with a light slide-in fit. I could pull it out by hand, but it's a little bit of a grunt, the mandrel. But by putting it in the lathe, in the collet, and it's a Harding 7/8 collet, I have a reasonably true rotational axis with the lathe here, the Sagami. So the mandrel spins true, which is captured in the bearing bores of this casting. So the casting now is rotating relative to the bores, which kind of makes sense. And with that as a given, this register surface, which is scraped, should be perpendicular 90 degrees to that shaft, that mandrel, those bearing bores, that rotational axis established in this lathe. But it's wonky by, what'd I say? Direct reading was 10 thou right around the shaft, and the whole face is within, what did I say, 6? Yeah, 6. Well, it's not great, but it's not terrible. Do you think they scraped the surface in the headstock to align this with? I don't think so. You know what I'm saying? Because this is off, do you think the scrape surface? Well, let's go see. Let me take you off the mag base.